Poundland have recently introduced two new USB power supplies. The only ones they've had in the past have just been they've had random bursts of power supplies, but this seems to be a standard ongoing product line by the look of it. And I thought I'd give them a test, and I've got fairly high hopes because, to be honest, I've opened Poundland similar stuff in the past and it's all been electrically compliant. And that is the complete opposite to Pound World. I don't really recommend power supplies like this from Pound World because they've been in the news recently with some of their more dangerous supplies. But Poundland, I'd say, okay. So let's investigate these. And the first thing I'm going to do is I'm going to give them an electrical insulation test. And for that I'm going to use a PAT tester, portable appliance tester. And to test between the input and the output, I'm going to use a double insulated appliance test, but I've got the earth test lead, and I'm going to plug it, this little adapter I've made, into the output, and it's shunting positive and negative together and connecting to earth. And I'm just going to plug this in now, turn the tester on, and do the test. The first thing it's going to do, it's going to come up with a low load test, a low load indication, because it's trying to detect the load of an appliance to make sure it's turned on. I'm going to have to confirm it is okay. So it's now doing an insulation test, and it's come up clear, and it's done a leakage test, and it's also come up clear, an AC leakage test, so that's good. So let's try the other test, the other USB power supply. I want to point out this is just testing them at 500 volts as a standard test. So let's plug that in there. In reality, in proper manufacturing tests, I think it would be a lot higher. So let's run the test again on this one. It's going to say low load, confirm. So they've passed. Okay, that's a good start. Now we can plug them in and try them out. I want to clear up some misconceptions about PAT testing. Now, PAT stands for portable appliance testing. So when you're saying, this is where the pedantic people say, well, you can't say PAT testing then, because you'd be saying portable appliance testing, but PAT testing is what we call it. And you don't need a PAT tester to do PAT testing. All you need is an insulation tester. This unit will do all the tests automatically. It'll test it, it will test for leakage between the insulation on cables plugged into it, and it will also test the insulation integrity of an appliance. And in the case of the Class 1 appliance, which has an earth wire connected, it will also test it. You actually put the lead onto the metalwork and it does a test to make sure it is bonded properly. This unit only does a 200 milliamp test, which is perfectly acceptable in the regulations, but the better tests are the ones that do a real high current test of about 25 amps, I think it is. Is it 25 amps? They do a really just low voltage, high current pulse just to really test integrity of earth connections, because that shows up any sort of slack connections, stuff like that. But the 200 milliamp test is perfectly acceptable under the regulations for PAT testing. And as such, if you've got a standard Mega, an insulation tester, which has by default a 200 milliamp continuity test, and it does the 500 volt insulation test, you can do all the tests that are required using that. I should cover that in a separate video. There's also a bit of an industry around PAT testing, whereby if you go online and say, do I have to get training, you'll find lots of companies sort of using cryptic wording saying, oh yes, we can provide you the training you need. In reality, you don't need training, you don't need a certificate. Anybody can do PAT testing. The main requirement is that they know what they're doing, they understand the tests they're doing and how to interpret them. And once they've done the test, they can then put a label on the goods, and you suddenly recognise these labels. There's also a bit of folklore that you have to test an appliance every single year. In reality, it depends on the type of appliance. You know, if it's a higher item that's going out in the touring industry, it will get tested every single time it goes out virtually. But for an appliance in an office or something like that, it's likely to get tested once a year. And say for instance the vacuum cleaner, the cleaners or whoever use the vacuum cleaner will get told, if you ever see anything wrong with the flex, if there's any obvious damage, which is actually a major part of PAT testing, then report it. You know, it's all just common sense safety, but it's all got blown out of proportion. And you can buy these labels online. These ones came from www.patlabelsonline.co.uk. I think I got them off eBay. And they're not that expensive because they're such a common item. So now they've passed their test, I think I should apply the labels. So here we go. It was a pretty black case. It's now about to be a completely ugly case. And this is also a great opportunity to apply over any air vents. And now when people come in to check that the place is safe, oh look, I've just smeared that horribly, they'll look for these little green labels, and then just that'll be them happy. That's literally how it happens. You get smaller labels for things like this. Yes, right, okay, that's it. That's that job done. Anyway, now they're tested and compliant, let's test them. So let's bring the little voltage indicator in and the test load. Let's test this one first. Of the two, I'm more comfortable with this one. I like its shape better. This one is more like the cheapy Chinese ones you'd find. I've got less confidence in that style of case for some reason. So let's plug the voltage indicator in. And it's showing a dead on. It's 4.99 volts, 5 volts. It's like dead on. It's very good. That's a good start. Let's plug the load in. So with a load of 1 amp, well it's 950 milliamps, let's see what the voltage is. 5.11 volts. So it's holding pretty well. Let's put it up to, the voltage is now dropped to 4 volts at 1.4 amps. It's not designed to supply that, but it has passed its 1 amp test. Okay, that's a good start. Let's plug this one in. 4.85 volts, plug the load in. The voltage goes up, that suggests it's primary side monitoring, but it is supplying 950 milliamps at 5 volts. Voltage now drops to 3.61 when I put it into the 2 amp load. This is just a wee test you can buy off eBay. At 1.26, 1.28 amps. Okay. So this one I'm pretty sure, hold on, where's the specs? This one claimed, 5 volt 1 amp for this one, so that's doing fine. This one actually claimed 1.2 amp, and I have to say it did seem to actually have a higher power capability. Rightio, let's open them and take a look inside, because that often reveals so much more. I went and did portable appliance tests all around my friends' prop making workshops, and it always reveals such a lot of stuff, you know, silly things like the wrong type of fuses. Is there a wee label under that, or is there a wee screw to say? Nope, I think it's just clipped on. This may be destructive. It's off. Ooh, thick cables. Super mega clearance from one side to the other, with anti-tracking slots. That's good. It's based round little single chip generic-y type power supply, which is a let's see, that's a TO203 C162801 TD203. I think TD203 is the important bit here. So we've got the mains come in. It's going through a fusible resistor, 4.7 ohms. It looks like it's got a standard, probably a 1 nanofarad class Y1 capacitor here between the input and output. Yeah, yes, I think that is 1 nanofarad. So it comes in, goes through the bridge rectifier, gets smoothed, filtering, more smoothing. That's quite good, isn't it? And then the classic arrangement of the little power supply. Yeah, it looks okay. It looks quite respectable. It's passed its high voltage test, but I wonder if oh, look at that. No, that's even better. Can you see how they've actually extended it out here, and it is that double insulated wire? This actually looks quite good. That's a good start. And that's the one I was a bit suspicious about. This one I may have to break open. One moment, please. So that's this one open. It completely defeated the vice of knowledge. It took the pipe grips of perpetual inquisitiveness to actually burst this open. And it reveals a completely different construction inside. I was kind of expecting them to be similar, but they're not. The only thing they share in common is an 8-pin package switch mode chip, but they're completely different chips, so they're not sharing that in common either. When you open it up, it reveals that there's a metal strip is punched onto the live and neutral connections, and it's got 2 little grip connections that go onto the solder pads here. This one has good separation again. It's got modest. I'd say this one has the better electrical separation. It's also got that. It's also got the little spark gaps as well there, which is neat. I think that's what they're trying to do here as well. But with an island in the middle, it's the same sort of effect across the Y1 capacitor. The Y1 capacitor is 1 nanofarad again. The transformer has also got that extended insulation, the thicker insulation, the extended leads coming out. It's also got the rectifier. Let's see, I'm getting the right one here. No, let's look at the right one, shall we? It's also got the rectifier, then going to the capacitor, then the inductor, and then capacitor, so a bit of filtering. The chip number in this, it's not terribly helpful. SD6952S does pull up that it is a switch-on power supply. The other one, the TD203, pulls up a standard turntable. It's not terribly helpful. I couldn't track that chip down easily. But both fundamentally little primary side feedback chips with little bootstrap circuits as well to power themselves. And the output is what you'd expect. It's the smoothing capacitor and a diode on both of them. Diode, smoothing capacitor. And the middle pins, the data pins, on the wobbly case ones, they're just shunted together. On this one, they've got pads for resistors, but a 0 ohm link across them, so they're shunted together as well on the boxy shaped one. So look at them both. The boxy shaped one is actually more complex. They've both got good clearance. They've both passed those tests. They look as though they may have traceable transformers, which is interesting, particularly this one's got numbers on it. They both look pretty good, to be honest. But I'd say the boxy shaped one has so much more support circuitry, it's got an awful lot of components versus the simpler, the wobbly cased one. And that means the one I was thinking was the one I was dreading opening. I thought it was going to be pretty bad. Is actually perhaps my preference of these two, because it actually does look like a decent design. So I'd say that once again, Poundland have pulled out some good enough products. Neither of them has the opto-isolated feedback. It's all strictly done from the primary side. So the voltage will vary slightly around about 5 volts, but from the tests earlier it wasn't too dramatic. So I would say they're perfectly serviceable little power supplies. I wouldn't mind doing a higher voltage test on them, but the separation of them is enormous, so they look quite respectable actually, which, as I say, is what I'd expect from Poundland, because they normally do produce modestly respectable mains voltage stuff. So yeah, interesting. They get the seal of approval for £1 anyway, because that's good value. And you know, these things are perfect for powering things like USB lights, or I'm not sure you should ever really consider plugging a really hugely expensive iPhone into something that costs £1. But certainly things like, you know, the plasma globe, or the strings of LED fair lights, or just other little night lights and stuff like that, these would be perfect for supplying those as a sort of reasonably isolated supply.